today we're going to talk about note 6, which is functions. Okay, so with functions, it's not super difficult. The big thing is when you have like y equals, okay, the big thing with functions is y equals really means f of x, which means function of x. Okay, so functions are not super difficult. Okay, f of x and y are equal to each other. They're interchangeable. They're the same thing. So we have this thing called specifically function notation. And function notation, all it does is it takes a y equals equation. So if I have y equals x plus 2 and changes it into function notation. Okay? Now function notation means that we have an f of x. So with function notation, here's how it changes. You ready for this? F of x equals x plus 2. Did you see that? Did you see how crazy that was? So all we did was we changed the y to f of x. So here's where it really is going to get to you. When we go into algebra 2 or into pre-cal or calculus and stuff like that, you use function notation a lot because what you really do is you take like function of x as part of or y. It's like this whole big thing. So that's where you really see it used a whole lot. Now, f of x, the function notation form can be anything. So if I have like y equals 3n plus 1, but I want it in function of k, I can have k to the n equals 3n plus 1. Okay? It doesn't necessarily always have to be f. A lot of the times it's f and g and h. Those are the three common ones. Those are the most common ones, f, g, and h. But it can really be any letter. Okay? Are there any questions on this? Okay, so let's create a table of values. So if I have like y equals 2x plus 1, and so I've got my x, 1, 2, 3, 4, and my y, and I have when x is negative 1, 0, 1, and 3. Okay, so we're trying to find our y values. And we're not using our calculator, okay? All this is like when we evaluate functions. When x is negative 1, what is y? So if I plug in my negative 1 for my x, what would my y value equal? Well, 2 times negative 1 is negative 2, plus 1 is negative 1. If I plug in 0 for x, 2 times 0 is 0, plus 1 is 1. If I plug in 1, 2 times 1 plus 1 is 3. If I plug in 3, 2 times 3 is 6, plus 1 is 7. Okay, so this is part of a function. Figuring out what your x value, if you have your x values, what your y value is, and vice versa. If you have your y values, you can figure out your x values. Okay, so if you have your y values, y equals x plus 10. Okay, and I've got my input and my output. It just means x and y. Input, output. But I have my y values this time as 12, 8, negative 20, and 0. Okay, this one's just a little more complicated. Now, it shouldn't be for you with this specific problem, hopefully, because it's plugging in 12 for y equals x plus 10, which equals, oh, I made that a little too close. Let me try that again, just so that I have more room to write my actual answer. So if I have 12 equals x plus 10, well, if I'm solving for x, I gotta move my 10, so do I add, subtract, multiply, divide? Really? Subtract. So 12 minus 10 is 2. What about when my y is 8? I subtract 10 and I get negative 2. When my y is negative 20, I subtract 10. Think on that again. Negative 20 minus 10, negative 30. And when it's 0, I move my 10 and I get negative 10. Okay, so these are just a couple of different ways. It's not super difficult. Okay, so we use an acronym to try to remember all of our little hints on domain and range, because that's what we're getting into today, is domain and range with functions. We use Dixie-Royd, okay? So D-I-X-I, and then we have R-O-Y-D. Dixie-Royd. So here's what it stands for. D stands for domain. Okay. We already talked about it, the input. Okay. And it's the x-axis. I'm going to fix that one too because I don't like it. And it's the independent variable. Okay? It is independent, it is on its own, it does not require y, it just requires itself. When we're talking about range, or Royd, we've got range, we've got output, it's the y-axis, and it's the dependent variable. Are there any questions? Okay. So if I had a set of points, what is the domain and range of, I've got 3, 5, 3, 6, negative 1, 8, 0, 15, and 4, 9. So if I'm looking for my domain, I'm going to move this up some for you. What are my domain values going to be?
The x-axis.
Okay, the x's. Do you remember in an ordered pair which one my x and which one my y is?
Yeah, it's the first one.
XY.
The first one, it's always xy. So what do you think the values of my domain would be for this one? 3 or 5? 3. What about this one?
3.
What about this one? And here?
0.
And here?
4.
Okay, so those are my domain values. Now when we're talking about writing domain values, the big thing is you need to write it in from lowest to highest without repeating numbers. Okay, so it goes, let's write a note on my side. Lowest to highest, no repeating numbers. So when I'm looking at these, I've got 3, -1, 0, and 4. What's my lowest? -1. Then what's my next lowest?
0.
And my next lowest?
3.
And my next lowest?
4.
Okay, because we cannot repeat that 3 that we already have. Are there any questions with any of that? Okay, we're
You
gonna,
see this on like graph problems, like there'll be a graph with points and it just acts as like,
yeah, we'll get to that. We'll do that in, I think, 7 or 8, one of those two. But we'll get to that one. Okay. For now, it's just like from a table of values and from a like from points. So what about my range? What would my range be?
your lives.
My Y's. So that's the ones that are left over in here. So what's my smallest?
5.
Then,
8. Or wait, yeah, 8.
then,
9.
and
15.
okay, so you could have, like for my domain, I only have 4, and for my range, I have 5, and that's perfectly fine. Okay? So are there any questions? That's it.